Hi, this video is about a relatively new feature in GHC and Cabal called multi-home units. So I'm not going to explain what that means, but we're going to go through an example, and the example will show what multi-home units are and why they're good. Now, in my opinion, this feature is a complete game changer in terms of Haskell development, and it's something that I think everyone should know about and everyone should be using. That's why I'm making this video. So let's jump right in. So I have VS Code open here, and I've just loaded an example project. I've chosen to use Servant, the popular package from Package Servant, and we're going to use this as an example that we're going to work with. So I've loaded up in VS Code. Now, Servant is actually, it's a mono repo. It has lots of different packages in the same Git repo, and then it uses a cabal.project file to sort of load them and link them all together. And multi-home units actually work really well in this setup as well, but they're also useful just for a single package. And we're only going to be using a single package servant server, but just know that it works really well also with this mono repo type setup. So servant server, if we open the cabal file, it has a very specific structure that's common to lots of packages. It has a library where it defines all of the modules that we can import and users of Servant can use. And it also has a test suite. And this is where the unit tests and other tests are written in. And it's separate from the library because it keeps the code separate, and also any kind of dependencies that are only needed for the tests don't need to be part of the library itself. And we'll see the test suite itself actually depends on servant server, which is the library we saw above. So this is a very popular setup, and it's a really nice setup and recommended. And then what we want to do is, if we want to actually run the tests, we can use cabal test servant server, and this is going to compile the library. Then it's going to compile the test suite. Here we can see it compiling the library. Now it's compiling the test suite. Then it's going to run the test suite, and we're going to see that hopefully all the tests run and pass. Here we go, and boom, and it ran all the tests, and it's all green. Great. Now, as we're working on our project and we're developing, we're going to be editing the tests, and we're going to be editing the source code of the library. So let's go ahead and edit the one of the tests. So I'll go into the test directory here, and I'll just pick any random test. So I already marked the one I'm going to be working on right here. So if I change this test and I just break the test, instead of 404, we return 403. Now I want to run my test suite again. Well, I can go back to cabal test. This time I'm just going to add the Unix time command before it. It's just going to tell me how long it took. Now when we run this, it's going to compile the test suite, link it, run it, and we see I broke my test, so we get a test failure. But the interesting part is that it took 3.5 seconds. Now, 3.5 seconds is not a whole lot of time, but it's still kind of annoying that I have to wait every time I make a change, right? If I fix it now and run my test again, I have to wait that 3.5 seconds. And when you have larger projects and larger libraries, instead of 3 seconds, it can take 10 seconds, 20, 30 seconds. The waiting time is very, very frustrating and annoying. Having this fast iteration times is very important for software development, in my opinion. Luckily, GHC has the answer, and that is GHCI, right? GHCI is a repl that is able to immediately run Haskell code without compiling it. It just runs it interpreted, and this is a great solution. So instead of compiling it, we can actually load our code in the repl. So instead of running cabal test, we can run cabal repl, and we're going to tell it, okay, load up our tests in the repl. So we want to load in servant server, but the tests. So if I go to the cabal file of servant server, we can see the test suite, and it's called spec. So I need to actually say :spec. And now it's going to load in our test suite, but inside the GHCI interpreter. Now I can run our tests by running the main entry point, and it runs our tests. And if I run it again, you'll see it doesn't need to recompile it. It runs our test suite immediately. More important though, if I go into my test and actually break my test, instead of having to recompile, I can just run reload, and it's instant. And now when I run my tests again, boom, it runs immediately. There's no compilation, there's no 3 seconds, there's no 10 seconds. It's very, very fast. This is really amazing for working. You get really fast iteration time. Now if I fix my tests, I can do reload. Again, we're going to see it loads it instantly, and my tests run straight away. So what's the problem? The problem is I've been only changing my test right now. If I go into the actual library code, for example, this file right here, and I break my library code, and I try and run my test suite again, if I do reload, we see it's instant, but it doesn't actually say anything. It doesn't detect the change, right? If I run main now, all the tests pass, even though I've broken the code, right? We can check that by running cabal test. And now we see, again, it needs to recompile everything, and I have to wait and get bored. And this time it took 5 seconds, and at least it's giving me a correct result that the code is broken. So now if I go ahead and fix it, again, I have to do cabal test, compile it again, and I have to wait, and I have to wait that 4 seconds. I want instant iteration time. And it does not work in the repl because the repl is only loading my test suite. We see it here that when I load the repl, I actually told it only load my test suite. So the library code is being compiled and linked into that. It's not being run through the GHCI interpreter. So you can think, okay, instead of loading the test suite in the repl, let's actually load the library code in the repl. So I can do that by loading the library code in the repl. Now, this works. We can see if I actually change my code and do a reload, then we'll see it actually detects the change that I made to error formatter and reloads it. The only problem is I can't run my test suite in here because I don't have it loaded. So I'm stuck. This is where multi-home units come in. And like I say, it's a game changer. So what I can do is I can run cabal repl, and I'm going to load both units in. They're called units. I'm going to load the test suite and the library. So in order for this to work, I need to use the flag enable multi-repl. Now this is a new feature that's only available fairly recently. So I'm using GHC version 9.10.1 and cabal version 3.12.1.0. So I think these are the minimum versions you're going to need of both GHC and cabal. So now let's try it out. So repl, so we need to use this new flag, enable multi-repl, and then I can give multiple units instead of just one right here on the command line. So I can give it the test suite, and I can give it the library. Now the order here, I think it's important. I think you want to do it the order of the dependencies, sort of from the most downstream to the ones that it depends on. So in this case, the test suite depends on the library, so we need to put it first. I haven't played around with this a whole lot, but I think the order is important, so watch out for that. And now when I run this, it's going to load into the repl. We're going to see it load into the repl, the library as well. Here's the library as well as the tests. We can see that these are the modules of servant server, and that's the spec. Here are the modules of servant server, and here are the spec files of the tests. And now it looks like everything is going to work magically. So first let's run our tests. So it's saying command is not supported yet in multi-mode. So now we're kind of stuck. I can't run my main entry point as I did previously. So we need to be a bit more creative. So if we go into the cabal file, the test suite, it's saying that the main is spec.hs. So we want to run spec.hs. So if we load up spec.hs, the file is blank. And that's because it's using this magic stuff from hspec discover. So we don't actually know what our function is called. But if we think about it and kind of guess, we can say this must be the main module. And in Haskell, the main function is always called main. So let's just take a guess and try running main.main and hope that it catches this test file of ours. And spoiler, it's going to work. So let's run it and see it work. And it actually runs our tests. Now we're getting an error here, right? And that's because our code is still broken. This is going to give us a really good chance to see this instant iteration time we've been looking for and finally see it in action. So now if we go to our code here, and now we're in our library code, right? We're not in the test code, we're in the library code. We're going to fix the bug, save it, reload, and this is going to be instant. Watch. Boom. And now when we run our test suite, again, it runs instantly, and we got that instant iteration time. If we go back to our test and break our test code, will this work? If we break our test code, reload. Yep, it detects the change, and boom, our test code also runs instantly. So that's the main idea. It's fairly simple, as you can see, but I'm going to give you a few more tips. So the first tip is running a single test. So here we have a single test failure. It's telling me 204 tests, only one failed, and we can see all the green check marks here. And this test runner that we're using, it's actually giving me this hint. It's saying instead of running the entire test suite, you can just run a single test, the failed test. Now this is useful if you have a large test suite that takes a long time to run, even several seconds, and you want to fix a bug that's only affecting or failing a single test. Instead of running the entire test suite each time, you can just run a single test. So it's telling us what we need to use on the command line. Just use these flags. So it's these flags. We don't actually need the seed, but it doesn't hurt. But we won't copy it. So how do we actually use this? So these are flags that you usually can just pass to cabal test, but we're inside GHCI now. So what you can do is, and you might be familiar with it, this is not specific to multiple home units, but you can use the :set args. And now I'm going to copy the flags that it's telling me to use. And now it's modified sort of the arguments that are always going to be used from now on in this GHCI session. So now I'm going to run my main.main again, and instead of running the entire test suite of 204 examples, it's just going to run that single failed test. And we see it runs much faster, and it's saying one failure, only one test run. So now I can go ahead and fix the test and do my reload, and again run my test suite, and now the test passes. Great. Now that I fixed my bug and my broken test passes, it's a good idea to run the entire test suite. So how do I do that? I'm going to do again set args, but this time with no additional arguments. Now it's just going to clear out the arguments, and then it will run all of my tests. Boom. So that's the first tip. Already you can see this is really, really convenient. You don't have to ever leave the REPL. You can work with your library code as well as your tests, make modifications, reload, run the test suite, make changes, reload, run the test suite. Everything just works. I'm going to give one final tip just for an extra increased productivity, and that is by figuring out this typing reload and running the test. It's kind of annoying. Let's try and automate that. So I'm using VS Code. So I'll go into my preferences, keyboard shortcuts, and then up here, there's this little button for the JSON configuration of the keyboard shortcuts. So I'm going to click it. Now, you might have this file completely blank, or you might have a bunch of custom stuff that you added. But what you want to do is add this new command that I've written, and we're going to read through it now and see what it does. So the first thing is the actual keyboard shortcut we're going to bind. So I chose F9. You can choose whatever you want, but this is the key I like. And what this is going to do is it's going to be kind of like a macro or an auto key, and it's going to just run a series of commands that we've defined here. So what is it going to run? First, we save all my files. This just saves the step of having to do a manual Control S or manual save and then run F9. It just does it for you. Then this is a nice touch. We're going to clear this the terminal, the built-in terminal. We're going to clear it because it just helps see the output a bit better, so we don't have to worry about noise that's already there. Scroll to bottom. This seems kind of redundant because if we're clearing it, why do we need to scroll to the bottom? Well, turns out it's just sort of a quirk in VS Code that I noticed where if you don't do scroll to bottom, sometimes the clear doesn't actually work right. So you just have to add the scroll to bottom. And this is the actual important part. We're using terminal.send sequence. So this is going to sort of inject keystrokes right into our terminal so we don't have to type them ourselves. Right? Instead of typing :reload, we're going to inject those keystrokes automatically through our command. So it's going to inject :reload, and then this is the enter key. That's the code for enter. And then it's going to type our main.main to run the tests, and then it's going to hit enter again. Once you add this snippet into your keybindings.json and you save your keybindings.json, it should take effect immediately, and you can press F9. So I'm going to do it right now. I'm going to press F9 right here in my editor, and we're going to look at the terminal here at the bottom and see what happens. Wow, so it was so fast you couldn't see it, but it actually did the reload and it ran our tests. So now let's go back to our library code. Let's try and break it again. So I'm going to change it to 403. And now I don't have to save. I'm just going to press F9 and boom, instantly runs our test. It sees I have test failures. I can fix it, rerun the test with a single keystroke. You see how fast this is, this iteration time. It's instant. You can compare this with the previous, cabal test. I don't have to wait now for 5 seconds, 10 seconds. If you have a really large project, you might be used to really long compile times. This is going to make it much, much, much faster, at least like 10 times faster going through the repl. And it's truly a game changer. And the nice part is we still have the repl sort of here open, so I can still use that trick of set args, right? If I'm working, even though I'm using my keyboard shortcut F9, let's say I broke my code. So now I broke 17 tests. So let's just say, I just want to work on fixing this single test, this one. So it's telling me the arguments I need to pass. So I'm just going to copy it, set args to this one. Now I can, try running my test again. Oh, it's still broken. Let's fix it. Boom, it passes. Great. Now I want to run my whole test suite. Let's clear out the args. Boom, run the whole test suite. Everything works. I can go back to my tests, modify my tests. Let's break this one. Boom, test breaks. Let's fix it. Test passes. It's just amazing. It's beautiful. This is how things should be, and it's great that Haskell workflow we finally have all of us have access to this type of workflow, because it really is, like I say, a game changer. It makes you so much more productive, so much more efficient, and being able to stay in the flow and not have to wait and wait. You get that instant iteration. That's it. That's all I have. So I hope this video helps you, and thank you, and happy Haskelling.